Howdy ho neighbor, we're off to Algebra 2 Mod 3, Unit 8, Lesson 4, the most important property of logarithms. Let's take a look at base 10. So we are going to use this table over here to get the decimal values of various logarithms. Yes, it can be done in the calculator and we'll deal with that later, but we're going to use this table, old-fashioned style, on how to put it together by hand. So if I look at log of 80 up here, our first example here, basically that's the same thing as the log of 8 times 10, which is the log of 8 plus the log of 10. Now why do I say it's plus? If you remember, logarithms are basically part of exponents here. And when we multiply same base, same pieces here, and the same bases are basically through the log, is log base 10 of 8 and 10, you basically add them. So we know that the log of 10 is equal to 1. It's 1.0. It's not on this table, but basically 1.0000. And the log of 8, if you take a look at your table right here, says it's 0.9031. Add the two together, you get 1.9031. Alright, take a look at 7,000. Well, that's going to be basically the log of 7 times 1,000. If you remember, a log of 1,000 is 3, so basically I got to take the 7, which is the 0.8451, and add 3 to it, so you get 3.8451. The next one here, a little tougher, log of 6 times, and you got to look at it, it's negative 1, 2, 3, 4, 5, so 10 to the negative 5th. That means I get the one for 6 there, 0.7782, plus a negative 5. So you get, that's a little trickier though, you're not going to tell me negative 5.7782, okay, you got to do the actual subtraction, and you will actually get negative 4.2218. And if you're starting to get in the hang of this here as far as it goes, the next one will be, you got the log of 3, so we know that is 0.4771 plus 10 to the 27th power means 27. So you got 4771, which puts our generic one here, log of 9. You look it up in the table, you've got 0.9542. And plus 10 to the k, which means, you know, by log base that is k. Now we don't know what k is equal to, so I don't want to call it k 0.9542, just leave it that way. Alright? Alright, now on this one here, basically tells you to use the calculator, complete the table around the 4 decimal spots. Well, a log of base 10 we know is 1.0000. Okay? And if I go and punch in and hit the log button on your calculator on the left side there, and then hit the 12, you will get 1.0792 rounded off. So, pause the video, fill out the table, and then double check your answers. Okay, so you should have gotten those answers, and the last one I got to fill in here, log of 100, which we know since it's got 2 zeros, it's 2. So 2.0000. That's filling the table, so we have even more places to go. Alright, so now we're going to calculate out some more values here. Log base 2, we know that's 0.3010 according to the table, plus log base 4, so it's already separated for you, 0.6021. Add them together, and you get 0.9031. And then they ask you here, do they appear anywhere else in the table? Where do you see that 0.9031? And I would hope you see it right here at 8. So this is saying same thing, You want to identify as approximately the log of 8. Alright, I want you to try the next bunch through F and calculate them on your own. I'm going to pause the video and then I'm going to come back with all the answers. Alright, so if you did this, log of 2 and log of 6 turns out to be 1.0792, which on the previous table on the previous page, if you look at log base 12, is 1.0792. So this is approximately the same thing as log of base 12. So log, not base 12, but log of 12. This one also turns out to be log of 12. Then the next three all turn out to be the same thing as the log of 36. So this is a log of 36 and log of 36. So there's a pattern here. I want you to take a look at these numbers here, and if you're looking at them, okay, how does log of 2 and log of 4 give you a log of 8? Log of 2 and log of 6 give you 12. 3 and 4 give you 12. 6 and 6 give you 36. 2 and 18 give you 36. 3 and 12 give you 36. So let's go on to the next questions and answer what that comes down to and what your hypothesis is on that. So I'm hoping that you get that the log of, if I'm taking the x times a y, is the same thing of log x plus log y. Or what you were seeing in the previous page here, if I have the 2 and I'm adding them, it's the same thing as multiplying, like the 2 and the 4. I add log of base 2 and log of base 4 to get 8. But if you multiply 2 times 4, you actually get 8. Okay? So what can we come out of that? Here's the next pattern we're looking at. And the one I look at was the one where we had log of 6 and log of 6. Well, isn't that 6 squared? Okay, when you're thinking of that one, that was log of 6 being squared, the same thing as log of 36. Okay, so what happens? It's the same thing. We had 2 of those things. So we had the log of 6 plus the log of 6. The x squared, you can actually take the square out and put it out in front, so it's really 2 times the log of x is the rule for that one. And so if we naturally extend it, log of x, y, and z should be the log of x plus the log of y plus the log of z. Okay, so let's apply this to a couple of things here. I've got log of 14 here. How can I break that up? Well, that's the log of what? 2 times 7. So all you're doing is the log of 2 plus the log of 7. And if I do the math, you go look in your tables there, you got 0.3010 plus 0.8451. And if I do the 2, you basically get 1.1461. Log of 35 is going to be the 5 times 7, so the log of 5 plus the log of 7, which basically gives you 0.6990 plus 0.8451, which is approximately to 1.5441. Okay. Once again, yes, I could punch on the calculator and check and just do log of 35, and you'll get that on the calculator. But right now, we're just busting up the pieces, which should basically re-emphasize exponential. If I'm multiplying the 2, what do I do with the exponents in a sense? I add them. The same thing's happening with the logarithm here. Okay. So, pause the video and try log of 72 and log of 121 again, and use your tables from the previous pages and what you know, and let's see if you can get those right. Okay, log of 72 should have been 8 times 9. Add the two individual pieces and you will get this. 121 is interesting because if you thought of it as 11 squared, you could have done 11 11 and added the two pieces. But remember, 11 squared, we can take the square, put it beforehand, so it's 2 of those log 11s. So double the log 11 and you get this answer. Now I know that's not in the table. You can double check with the calculator. So now we're actually going to do the calculator. So let's actually use your calculator to figure out all these things here, and you can do the fractions of the logs too. So, for instance, if I take a look at here, calculator, if I punch in log of 2, guess what? It matches your other one, 3010. And if I put in the log of 4, I will get 0.6021. Now don't be afraid of putting in a fraction. I can do the log of 1 divided by 2, and I will get a negative 0.3010. Okay, I want you to fill the rest of the table out, and then we're going to talk about this and come up with some stuff. So, I hope you had no problem punching these in the calculator. You get your table here. And of course, once we get down to 100, that's got 2 zeros, so that's 2.000. I want to see if you notice anything here going along this side. Look at this column, 0.3010 and a negative 0.310, 0.6021 and a negative 0.6021. And what patterns do you come up with? What can you predict 1 over 100 will be? I hope you can predict it, negative 2.0000. So these are the reciprocals of this, and if you remember, reciprocals was flipping, which if I was flipping was the negative power, and now the negative power comes out front, so there's a relationship here. So what pattern can we come up with? I want you to pause for a second again, and on number 7, think about that heavily here and see what you can write down. Now I'm going to get a little more technical here, because I'm going to basically say, for any real number, we're not in the imaginary world, we're in the real world, any real number, okay, x being greater than 0, what rule did you notice here? Well, hopefully you realize that the log of 1 over x, okay, that's this side here, what did it turn out to be? Was the same thing as the negative of the log of the other number, the x, when it was flipped the right way. That's the big key piece that we got to come out of this, okay? So if you flip the thing, all you got to do is take the negative of the same value. All right, we're almost done here. Okay, what I want you to do is pause the video and try B and C real quick, and then I'll get you the answers. Okay, any questions on those? We'll talk about them. Please bring them to class. The last one here, D, of course, we got the reciprocal thing. So remember, we're going to apply this last rule here. It's the negative of the log of 640. So now I want you to pause the video and try that one to finish that off. Okay, so if you actually do the work here, you got the negative of the log of 10 times 64. 64, I did 2 log 8s then in the log of 10. Log 10 is 1 plus 2 of those log 8s, and you get that answer. The key thing are these 2 rules. I'm running out of time on the video, so have a good day. We're going to talk a lot more in class over the next day or 2 on this, so we can get good practice.